Hello everyone, I am Amit Kumar Yadav from Electrical Department, SIIT College Bhopal. Today in this BEEE subject, we are going to discuss efficiency of the transformer. So let us start. As you know that the efficiency of the transformer is defined as the ratio of output to input power. It is denoted by eta. आप सभी को मालूम है एफिशिएंसी किसी भी बॉडी का या किसी भी सिस्टम का नॉर्मली आउटपुट वर्सेस इनपुट होता है. तो यहाँ पर हम एफिशिएंसी डिस्कस कर रहे हैं ट्रांसफार्मर का. सो इन दिस केस द एफिशिएंसी ऑफ द ट्रांसफार्मर विल बी output power upon input power, and this efficiency is denoted by eta. Okay, now look here written as output power upon input power, but as we know that this input power can be replaced by output power plus losses. आपको मालूम है कि हम जो भी इनपुट सप्लाई दे रहे हैं ट्रांसफार्मर में वो दो पार्ट में कंज्यूम हो रहा है. पहला एक आउटपुट पावर जो लोड को जा रहा है लोड के वर्किंग के लिए, एंड द सेकंड वन इज द लॉसेस विच इज एसोसिएटेड विद द ट्रांसफार्मर. ओके, since the output power is always less than the input power due to the loss, the efficiency of the practical transformer is always between 0 and 1, that is 0 to 100%, but it can never be 1 और इट कैन नेवर बी 100%. ओके, देखिए आप ये चीज़ समझ सकते हैं कि एफिशिएंसी नॉर्मली होता है आउटपुट अपॉन इनपुट. ठीक है, और इनपुट से ही आउटपुट जनरेट हो रहा है. तो आप एक चीज़ क्लियर समझ लें कि एफिशिएंसी कभी भी 100 से ऊपर नहीं हो सकती, या एफिशिएंसी 100% से ऊपर नहीं हो सकता, या 1 से ऊपर नहीं हो सकता. बट 1 या 100 किस केस में होगा? आइडियल केस में. बट एज वी नो दैट प्रैक्टिकली आइडियल केस नहीं होता है. इन प्रैक्टिकल सिस्टम हमेशा एफिशिएंसी बिलो 1 होगा या बिलो 100% होगा. ओके, देयर मस्ट बी सम लॉसेस ड्यू टू विच एफिशिएंसी कैन नेवर बी इक्वल टू 1 और 100% फॉर द प्रैक्टिकल ट्रांसफार्मर. ओके, so this graph of output power versus eta as shown here this y-axis is showing your efficiency percentage, and here this x-axis is showing your output. As you can see here, as the output increase, efficiency increase, but at a particular moment, okay, this efficiency gets saturated. Means at this level of output power, after this efficiency will not increase, it get saturated. And if you further increase the output power, efficiency will get down. That's why any element, any system work or give a maximum efficiency at a particular output. Beyond that output or below that output, you cannot get that maximum efficiency. Okay, now the output power at full load, how you can write the equation for output power? As you know that we get the output in the secondary side, and in secondary side we have V2 voltage and I2 voltage. And what is this cos phi 2? This is your power factor, where this phi 2 denotes the load angle. Okay, load angle between V2 and I2. So the output power at full load will be V2 I2 cos phi 2. So in terms of kVA rating, अगर ये जो हमने फार्मूला लिखा है, अगर हमें इसे केवीए के टर्म्स में लिखना हो, हम केवीए में क्यों लिख रहे हैं? क्योंकि नॉर्मली हमारा ट्रांसफार्मर की रेटिंग केवीए या एमवीए में होती है. इट ऑलवेज डील्स विद अ वेरी हाई वोल्टेज एंड करंट. ओके, तो हम इस इक्वेशन को केवीए में कन्वर्ट कर सकते हैं बाय यूजिंग दिस कॉन्सेप्ट. यहाँ पर वोल्टेज और करंट को अगर आप किलो वोल्टेज एंड किलो एम्पियर में कन्वर्ट कर रहे हैं, तो यहाँ से हमने 1000 का मल्टीप्लाई कर दिया. Okay, so your new modified equation for efficiency, that is eta for full load, will be kVA cos phi 2 into 1000 upon kVA cos phi 2 into 1000 plus losses. In the previous equation you have seen here, I have written here losses. Now as you know that what are the losses in the transformer? Basically there are two types of losses in the transformer. First one is core loss and second one is your eddy current loss. So this is this first one is your core loss and second one is your copper loss. So this Pi denotes your iron loss, means core loss, and this Pw denotes your copper loss. Okay, so this is the modified formula of efficiency in case of full load. But what happens if we do not use full load? If suppose if you use some partial percentage of any load, okay, then what will be the equation for efficiency? There will be a new equation for the efficiency. What that be? Suppose this x denotes the fraction of full load. It means suppose I have a load and I am using its only half, 50%. Then what will be the value of x here? The value of x will be 1 by 2. It means the value of x is here 0.5. So this x denotes only the fraction of the load you are going to use here. So just multiply this x with your numerator, and in the denominator multiply this x with your output power plus multiply the square of this fraction x with the copper loss. You are not going to multiply the x with core loss. Why? Because as we know that this core loss is always fixed, it's constant. Okay, it does not have any relation with the load. Okay, load may increase, load may decrease, but this core loss always remains the constant. So if you use any fractional load, it does not affect the core losses. Okay, that's why. And one more thing, load, the copper loss is totally depend on the load. It means as the load increase or decrease, copper loss also increase and decrease. So here if you use x percentage of the load, it means as you know that in load we use current as a square of the current. So here we use x as the x square. That's why I multiply x square with the copper loss. So this is your modified formula for the fractional load. Okay. Now come to the efficiency, means now come to the next topic, that is your condition for maximum efficiency. Now in this topic we are going to determine at what level, at what condition we can derive the maximum efficiency from any system or from any transformer. In this case we are calculating the maximum efficiency condition for our single phase transformer. So let us start. As we know that output power is your V2 I2 cos phi 2, and total copper loss in your transformer, which is here PC, and this PC is your I square I2 and R2, where this I2 and R2 are the secondary component, means parameters of the secondary winding. So according to these values, the efficiency for this transformer will be like this. Already you have studied in the previous topic. Now what happened in case of maximum efficiency? Suppose if you have to calculate maximum efficiency, then you just go through your mathematics formula. You just differentiate this formula with respect to I2. Why we are going to differentiate this eta with respect to I2? Because in this formula this I2 is varying according to the load. So when you differentiate this equation with respect to I2, then what you will get? You will get d eta by di2, and here you will get some values. Okay, and after differentiating this value, what is the condition for getting the maximum value? You just have to put this value with equals to 0. So what you will do here, whatever the first derivative of this efficiency you get, you just equate that value with 0, and when you solve this equation you will find that this core loss pi will be going to equals to this I2 R2. Okay, so from here what we can say that after doing all these things you will get a final equation, and that final equation will be core loss is equals to copper loss. It means for getting maximum condition in your transformer you have to put core loss equals to copper loss, or you have to put copper loss equals to core loss. होप स्टूडेंट आपको ये टॉपिक समझ आया होगा. थैंक यू.